Så där ja. Ja, tackar för det. Ja, är det någon som vill att jag pratar engelska? Anyone for English? Or? Yeah. Okay, good. Then we do it in English. So, first of all, I'd like to thank you for showing up on this little show of the Focus 3D laser scanner. My name is Marco. I came from ATS in Gothenburg, Sweden. And we are resellers for the Focus 3D laser scanner in Scandinavia and Finland. Should any one of you be from outside these countries and still be interested, I would be more than happy to convey the information to the proper sales representative within Faro organization. So I'm not going to do a lot of presentation about the company. I would like to emphasize on the scanner. And here is the Faro Focus 3. I think I put it here anyway, and hopefully it doesn't block the... There we go. So this is, I would say, the market's smallest, fastest, and easiest to handle scanner when it comes to laser scanning. And it's also very, very accurate. It's very easy to handle it, maneuver it. We store the data in an SD card, which I just put in here. It's a touch screen. Just give it a sec. There we go. A touch screen. This is the home. And here I can put in my parameters, saying how many points I would like to collect. So, and here I can say if I would like to have it in color or not. So I'll try that. Here I put it now on the 5th, which equals to 28 million points. That gives us, on a distance of 10 meters, it's 7.7 millimeters between the point centers. If we go further away, it increases the space, and if we go closer, it decreases the space. The scanner sends out a laser beam that reflects on this mirror. The mirror rotates, and we collect 320 degrees. The last 40 degrees down are in shade, so we don't get those. Should you want those, you can either put a scanner on the side, or flip it over and turn it on the upside down or something like that, so it's not a problem. The scanner then rotates horizontally. And since the beam goes out two ways, it's technically 2 times 180 degrees. So collect 300 degrees, 360 degrees, we only make half a lap. And then we get a spiral form like this, and it's sending out all these points. And every point has X, Y, Z, and if we wish, RGB information, as in red, green, blue. Because there's also a camera inside, and when we have collected the points, it continues another lap, half a lap, and it takes photos and put the pixels on the dots. Now, this is a laser class 1, so it's eye safe. So I'm going to scan in here now, and don't worry, there is no problem with the eyes or anything like that. I just want that for the record. I'm just going to put a little name here. So I call it speech. There we go. And then I go for the number. And here we go. When the machine is on, it has a solid blue light. When the machine works, it's in operation, it blinks blue. It has an inclinometer inside, so it adjusts itself. You don't need to worry about the levels. It does that automatically. You can put it on the side or hang it upside down. It will complain and tell you, I'm out of balance, but you can still scan. And now, with the red lights on, now it's scanning and operating. So this gives me a couple of minutes to talk about the company. Faro is an American global company, and one of the largest in the world, manufacturing measuring instruments. And the Focus 3D is one of them. The others are, for example, measuring arms and trackers. ATS, Advanced Technical Solutions, it's a little privately owned company in Sweden, in Gothenburg. And we are resellers for the Faro Focus 3D laser scanner in Scandinavia and Finland. And we also develop and produce reference system and scanning accessories for the scanner. So now you can see it's operating. Now we can't see the beam, but it is going. So for you, sit there, now you can breathe out again. And then when this has been finished, it's going to take another couple of minutes to take the photos. And it's quite interesting. So I was mentioning references. And in order to put several scans together to one unit, and if we want to scan, in this particular case, it would be probably mines or tunnels, we put out references in a good distribution. The scanner sees a reference. I didn't bring them, it's a ball, it's a white ball, sphere. It gives the reference an ID and a coordinate. And when you put the scanner in another position, it remembers that position and the coordinate. And with that, with minimum 3 of these references, we can put several scans together into one unit. If you wonder why I'm walking around a little bit, I've seen enough of myself, so that's why I don't want to. And it's also terribly revealing, so. So now we see, now we have taken all the scans, all the points. Now it takes a lap and it's going to check the ambient light. It may be a little bit too dark inside here, but I think it should be okay. And then it's going to take the photos. So, yes, and with the references, we can work together with, for example, the scanner and the total station. For you who are not surveyors, a total station is an instrument where you measure distance and location of various objects. And with this, we can build a coordinate system. So if you have, for example, a tunnel system or different orts in a mine, you can know exactly on the millimeter where every point is. And this would be useful. Let's say you have 2 different orts on different levels. Maybe they are not exactly in the same height. Then you can measure exactly how to drill if you want to make a shaft from one ort to another. Because you have everything in 3D, and then you can just calculate the angle. Now the scanner is taking photos. So it takes up to 70 megapixels, and it's going to put that RGB information on the dots. So you will see what it looks like. Has any one of you been in contact with laser scanning before? Oh, congratulations. Now you have a possibility to improve your knowledge. But I guess that's why we're here all are, aren't we? Again, this coordinate system, it's not mandatory to do it. However, it is recommendable to do that way because then you can know where you are. If you're driving a tunnel, for example, you can go in and you can document the tunnel as it is. And then after I'm done, Mrs. Sandström here will show you how to handle the data. And you can build models and see exactly if the blasted hole and the blasted tunnel is corresponding to what you want. So now we're getting closer and closer to the finish line here. So now it's getting finished for the last photos. There we go. It has a little bit of an ego, this machine. It goes around, oh wow, how good I am. It takes a little extra turn. Sorry? I didn't hear that. Very quick. So, here we go. Now we're done. And it is a little bit difficult to see, but we have a window here. Now we can have a look at the result to see that we actually captured what we wanted. 2 minutes more? Right, okay. I'll be very, very quick. And so what I'll do now is I will very quickly make a file. Documents, yes. Speech. There we go. Now I have made a folder called speech, and I'm collecting the scans called the scan called speech. I take a copy. I'm a little bit paranoid. I would not delete anything until I made my backup. I go back here, raw scans, paste it. Drag it in. So what it does now, it saves in the scan into the project. It does a little bit of filtering, and we are safe, and we're home, and this is what we get. The whole, ta-da! And if we want to look, this is the whole thing in 3D. There we go. This is what we got. And that would conclude my presentation. And I hand over to Mrs. Sandström from Adtolo, and he will now show you what to do with this material. Thank you for listening. And I'm in Iron in booth 314, I think it is, and you're more than welcome to come and have a chat with me after this.